So the first thing is the dot product. So basically you have two vectors and we're asking you to dot them. So the biggest thing I want to point out is the notation. If you'll notice, it'll look like this, u dot v. That's not u times v. This is vector's way of multiplying, okay? So that means the dot product. And so how you do that is it's actually rather simple. You just take the two I components or the two horizontal components, multiply them together. You take your two J components, which is the vertical components, multiply them together, and you add them together to get one number. So the result is what we call a scalar. It doesn't really have any meaning behind it, but the dot product is used in many mathematical formulas, which you'll see in a second. So it's just kind of like a skill that we need to teach you how to do. It doesn't necessarily have meaning on its own. But the key is it's not a vector at the end. You add them together to get one single scalar number. Okay, so consider two vectors, a u and a v. And if we say u dot v, we literally want you to just multiply them. And so you would get 2 times -3 plus -1 times 4, and you would end up with -10. And that's it. And again, it has no relevance. It's just, can you find the dot product? So one of the things a dot product is useful for is actually in the formula for finding the angle between two vectors. Okay, so the formula for the angle between two vectors is, you're going to take the cosine of theta is equal to u dot v over the magnitude of u and the magnitude of v. So remember, these double bars mean magnitude. Okay, and we're going to find the angle between them. All right, so we're going to use that, and we're going to use their two vectors u and v again. So if I want you to think about it, I actually drew these vectors for you. So 2, -1 is actually this vector here, and v, -3, 4 is this vector here, and I wanted to find the angle between them. So you can see it's a relatively large angle, but we can find it. So the first thing is we got to find u dot v. Now, conveniently, we already did that on the last screen, which we got -10. And then at the bottom, we want to find the magnitude of u and the magnitude of v. So remember, to do that, it's basically a squared plus b squared equals c squared. So 4 squared plus 1 squared, -1 squared, square rooted, and -3 squared and 4 squared, square rooted. So I got this. This is a 3, 4, 5 triangle, and this is the square root of 5. Okay? Now, this whole chapter is calculator, so you will need your calculator for this, and you will want to be in degrees, not radians. And so, oh, for a second I was, why is there 2? We had -6 plus -4 is -10, and then we divided by 5 to get -2. But it doesn't really matter, because at the end of the day, you need to figure out the angle, and so you're actually going to do inverse cosine, and we get 153.434. Because it's a calculator section, you do want to do 3 decimal places. And you can see our answer makes total sense, because this clearly looks like it would be 153 degrees. Okay, so this is how you find the angle between any two vectors. You find the dot product and divide by its magnitude, and then do inverse cosine. So why do you think we use inverse cosine instead of sine or tangent? That's a good question. And I hope you're thinking principal solution. It always comes back in every chapter. Cosine is actually the only one that will give us angles between 0 and 180. And so if you think about it, that would cover all the vectors, the angles between two vectors. Sine and tangent aren't going to do that, and they they abide by their principal solution when you use the calculator. It also, the formula for the proof for the angle between two vectors actually comes from the law of cosines. So if you're interested in that, that's something that you could look up. Okay, so a little insight. If you actually know what the dot product is, you actually have an idea of what type of angle you have without having to draw it out. Okay, so if you think about this formula, if I did u dot v, and I ended up with 0, that would mean the top would be 0. So the magnitude or the length of u and v are irrelevant, because you have 0. And if you do the inverse of cosine, what angle gives you the cosine of 0? It's actually 90. So if you end up with a dot product where the answer was 0, that actually means they're perpendicular. But in vector world, we actually don't use the word perpendicular. We use the word orthogonal. So perpendicular, orthogonal, and normal are all terms that mean that meet at a right angle. Perpendicular is common to see in our normal function world. Orthogonal is what we use in vectors. And then normal is when we have a plane and a vector. So we'll get to that in a couple units. But for now, when we say u and v are perpendicular, we're actually saying they're orthogonal. Okay, so then if u dot v actually has to be a bigger number than 0, you would have a positive number divided by their lengths, which would be positive. So when you do that, when you do the inverse cosine of that, you're going to have all the positive answers, which actually means you're going to have an acute angle, versus if u dot v was negative, their magnitudes are always going to be positive. So you have a negative, and so that puts you in quadrant 2, and the inverse of cosine in quadrant 2 is actually an obtuse angle. So just a little insight into like behind the angles.